So from that identity, all those other ones come in one way, shape, or form. So kids always say to me, who made all these up? No, no, no. They aren't made up. Every single one of those identities is derivable. They're not just pulled out of there. They're all derivable. We're not going to go into all that. But you got them all on your sheet. And we're going to add to that sheet. I think I maybe said in the video a couple things that maybe you would add on. That is up to you if you do it or not. However, we are going to continue on our conversation about solving equations, trigonometric equations. So I am picking up right where I left off, page 50. I'm on problem 4C, and these are the directions. So this tells me that I am going to be in radians. All right, if it said 0 to 360, that would tell me to answer in degrees. So I'm doing problem C that looks like this. Now, a couple of the other ones we did were like this, so you should have an idea how to begin. Does anyone have an idea how to begin? Subtract sign. Then what can we do? Now that we have it all on one side, now we can factor out a sign. If I factor out a sign, I will be left with tangent squared minus 1. Right? Now what do I do? After I factor, whether it's algebra class, trigonometry, whatever, after I factor, I set each of them equal to 0. So sine x equals 0, or tan squared minus 1 equals 0. Now, your job is to figure out x. Somewhere, there's an angle whose sine is 0. Now remember, 0 is special. Where do I look? When my number is 0, where do I look? Around the circle. So I'm going to look around the circle. And I am looking for what? The y coordinate is 0. Right? So you see one right here? So what angle is that? That angle right there is what? 0. That's 0. So one of my answers is 0. Now are there any other places? This tells me I'm going all the way around. I gotta go all the way around. Are there any other places that you see a y coordinate that is 0? Right here? So what angle is that? In degrees, it's 180. What is it in radians? Pi. Pi. 2 pi is all around, right? This is pi here. So the answers to this part of the question are 0 and pi. Okay, don't say 2 pi, because isn't 2 pi the same as 0? And it's not included. Parentheses, okay? So we should say 0 and pi. Now, what about this one? How would I solve that? Tan squared minus 20 equals 0. What would I do?
Add the 1.
I could add the 1 over. So one option is add the 1 over and then square root. That is my favorite way to do it, but you've got to remember, when you square root, it's plus or minus. You could also factor it, the difference of squares, tan plus 1, tan minus 1. That's how you get the 2 different answers. All right, so here I go. Now I'm looking around. I'm trying to figure out where can the tangent be 1? Never. opposite over adjacent? What kind of an angle has opposite and adjacent ones? This would be 1, 2. What kind of angle is that? 45? But I'm in radians, so I can't say 45. I have to say 45 is what fraction of 180?
Pi over 4.
Pi over 4. Now, all these angles are pi over 4s. Okay. Now, you guys, listen. This says the tangent could be positive or negative. Does not mean it could be any of these. Because here it's positive, here it's negative, so it's all of them. So what are all of those angles? One of them is pi over 4. What is the purple one? Now remember, this is pi. Isn't it 1 pi minus a fourth? So 3 pi over 4. This is 4/4. 1 pi, 4/4. So that purple one is 4/4 minus 1/4. What's the red one? 5/4. Because it's 4/4 plus a fourth. And then what's the blue one? 7, that's right, 7 pi over 4, because this is 8/4, that's 2 pi, so it's 8/4 minus 1/4. Nicely done. So, 1, 2, 3, 4, 5, 6 answers to that question.
So you can't do it. It's like sine for those, it's like extraneous. How do they extraneous that?
You can't do it if it says tangent of 90, or pi over 2.
Okay, so is that one of those? Is that one of those points?
Yeah. Yeah. All right, Harper, I'm gonna do one more problem, then I'm gonna get your question, okay? I'm gonna do problem D. Same directions. So, can anybody figure out anything I might do to solve that problem? Factor it.
Can we take out all of 4 cosine?
Actually, we can't pull out a 4 cosine because there isn't one here.
Oh, no.
This is factorable, Jimmy, in the same way that this is factorable. It's a quadratic. How would you factor that? Instead of a couple parentheses, what would they look like?
X squared. What should I do?
Would that work? With -2, -2 gives me -4, -1 times -1 gives me +1. That's right. So how does that translate to this one? What would these factors be? 2 cosine -1 and 2 cosine -1. Trigonometric equations are no different than algebraic equations. You can factor them the same way. If you wanted to, you could also do the quadratic formula. This is a quadratic equation. A would be 4, B would be -4, and C would be 1. And you would be solving for cosine x. If you want to do that. All right, what do we do after we factor? Set equal to 0. And I'm only going to write one of them down because they're the same. So doesn't this say cosine equals 1/2? So now I gotta figure out where the cosine is 1/2. It's not on the circle, you guys, because circles are zeros and ones. So it's someplace else. Where the cosine adjacent over hypotenuse is 1/2. Which means this is root 3. And this is 60. But I'm in radians. Pi over 3. Now these are all pi over 3's, but I don't think they're all going to be an answer this time. I heard somebody say, who said that? It's just the right side. Michael says it's just the right side. Because cosine is x, and that's positive. That's the right side. So no answers over here, just these two. So one answer is pi over 3. That's the black one. Now what's the blue one? Remember, this is 2 pi, which is 6/3. So all of it, except for a third, would be 5/3. And that's your answer. So that one only has 2. You never know. These things sometimes have a lot, sometimes have nothing. Okay? Now, we still got to do number 5 with our calculator, so go ahead and get out your calculator. I'm going to do Harper's questions. So Harper, what was your question?
On 3B, I guess it kind of applies to the one we just did too. So why don't you just do negative pi? That's one of the answers.
3B.
Or yeah, 3B, but why is it not negative 45? That's one of the answers. Like how it's
So you're saying when I solved this out, I got 315?
yeah. So how do you know when you have to go all the way around other than
This tells me that all of my answers have to be between 0 and 360. Is negative 45 in that interval? No. Now, is negative 45 exactly the same place as 315? Absolutely. But it doesn't fit the directions. Okay? Yeah. All right. Let's look at problem number 5. It says cosine x equals 0.37. I am to answer in degrees and radians. Okay, so we can only do one at a time. What do you want to do first, degrees or radians? Radians? All right, let's put ourselves in radian mode. And figure out where we are. Degrees or radians, it doesn't matter, we're the same place. Again, cosine is positive, and that happens over here. Would everyone agree with that? Now, when it was 1/2, I had absolutely no problem. 1/2 root 3, I got that. 0.37 is not known to me, so I'm going to second cosine 0.37. So this is what I type into my calculator. Anytime I need an angle, I need to use this kind of notation. So did you get 1.192? Make sure you're in radians. Because if you're in degrees, you get something different. We said we were going to do radians first, so it doesn't matter. All right, are we good so far? Now that means this is also 1.192. So my answers are going to be the red angle, which is 1.192. And then the purple angle, which I will find how? How will I find that? 2 pi minus that number. this was 2 pi minus 1.192. Because all the way around is 2 pi. Okay, now, we want to come back to what Harper asked about. Because this problem does not have those directions. Would you agree? It says find all of them. So like in this problem or that problem, when 315 was an answer, negative 45 is also an answer. There's nothing to kind of hold me in. So these are my two like starting point answers, but I have to add and subtract revolutions. Because when I add or subtract a revolution, don't I end up in the same place that I started from? And in radians, a revolution is 2 pi. So this means add multiples of 2 pi. So add 1 2 pi, add 2 2 pi, add 3 2 pi. So this would be all of the angles that stop where that red angle stops. And then these the same thing. This is just a math way of saying, take your angle and add or subtract spins. In radians, a spin is 2 pi. So I'm adding 2 pi's. 1 of them, 2 of them, 3 of them, 4 of them. These are called the coterminal angles. We talked about those one day. Coterminal. Add or subtract the revolution. Here I'm adding and subtracting all of the revolutions.
What is the like N?
That means, so there's an N here. This means N is an element of the whole numbers. It tells me what N is. N is either 0, 1, 2, 3, 4, 5, and so on. It's the number of revolutions that you're taking. Now, we need to do the same problem in degrees. It's going to look exactly the same. I'm going to set my calculator in degrees. I'm going to type second cosine 0.37, and this time it's going to say 68.284 degrees. So my red angle is 68.284 degrees. What is my purple angle? Now remember, you're in degrees. This is 68.284. This is 360. So isn't the purple angle going to be 360 minus 68? 291.716. And then, just like before, it told me to find all of them. So if I have to find all of them, I am going to add or subtract what this time? Not multiples of 2 pi, but multiples of 360. So 360 then. Multiples of 360. I haven't done that with any problem up to this point because those problems limited me. That limits me. That says once around. If that's not there, then it comes back to what Harper was talking about. There's more than one way to name these angles. All try number 6. Tangent equals 5. I know that I am gonna have to type second tangent 5 or inverse tangent on my calculator. Do you agree with me? But before I do that, where can the tangent be a positive 5? It can be a positive 5 in quadrant 1. Where else can it be a positive 5? 3. Why is it, you're right, why is it positive in 3? Because tangent is opposite over adjacent, y over x, and they're both negative down here. Right? So, I am setting degrees currently, so I'm going to second tangent 5 degrees, and I got 78.69. Huh? And I am in degrees. If you're in radians, you'll get something different. You have to do both. You have to do both, so I did degrees first this time. And now I need to write my answers. So one of my answers is 78.69. Would you agree with that? How am I gonna find the blue one? What is the blue one gonna be? Add 180, right? Isn't this 180 over here? So I'm gonna add 180 to that. I got 258.69. If these were the directions, I would be done. That is it. But those aren't the directions. It says find them all. So I have to take these and add or subtract revolutions. In other words, find all the coterminals. Okay? How do I do that in degrees? I add plus or minus multiples of 360. Now, for practice, we're going to do the same problem in radians. We're going to change that to radians. Second tangent 5, and this time I get 1.373. So in radians, same problem, but in radians, one of my answers is that right there, quadrant 1, whatever the calculator says. How am I gonna get the purple one now? Radians and pi. 4.515. Add pi. Pi plus that angle. And then, since it says all angles, I have to add and subtract revolutions. And what do revolutions look like in radians? 2 pi's. There we go. We're all good. Everybody okay? One homework one you want to do. So get out your homework. Pick a problem. The first three are simplified, and the last one is a solve.
Simplify 2.
Simplify number 2? Alright.
Question 2.
Alright, so we're gonna simplify this. So, just pretend for a moment that you were walking down the sidewalk and you found this problem. Knowing no trigonometry, not having your reference sheet, what would occur to you to do when you look at this problem?
Multiply on the top.
What?
Multiply.
Multiply out the top. Isn't the top a FOIL?
Yeah.
We're just gonna multiply out the top and see what happens. So we have secant times secant. That's of course secant squared. Outsides
Real one.
insides, and less. So the numerator is 2 parentheses times each other. When I don't know what else to do, I'm going to FOIL every time. Now, what happens with the FOIL? The middle cancels. So now I'm left with secant squared minus 1. Now, because I'm old, and I've done this for a long time, my heart is just singing right now. Because that is something. Look on your reference sheet. This is something. Can anybody figure out what that is? Well, secant squared is 1 over cosine, but that's not what I'm talking about. It absolutely is. That is true. Secant's 1 over cosine. One of your Pythagorean identities says 1 plus tangent squared is secant squared. See that one? See it?
Yeah.
What happens if I move that 1 to the other side? Then it says tangent squared equals secant squared minus 1. Would you agree with that? You are allowed to do that. And in fact, if you want to add this to your sheet, you may. It's the same thing, just in a different order. So secant squared minus 1 is the same as tangent squared. So I'm going to write that as tangent squared over sine squared. Would you agree with that? Now, guys, that's a division problem, right? What is tangent? Look on your sheet. What's it say? Did I add it on there? I didn't, but you can. What's tangent? Add this to your sheet. Tangent is sine over cosine.
Cosine.
I think we already knew that, but I'm gonna add it on the sheet anyhow. Right down there, good for you. So this is sine squared over cosine squared over sine squared. Now, many of you are probably uncomfortable with complex fractions, so let me remind you that what this says is sine squared over cosine squared divided by sine squared. That's what this says. fraction is multiplied by the reciprocal. Keep change flip. So sine squared over cosine squared times 1 over sine squared. Yeah, right kind of small, so these all this in. What happens now? I turn this into a multiplication. Don't those cancel? 1 over cosine squared, which we know 1 over cosine is what? Secant. So your answer is secant squared. That boils down to secant squared. So your job was to simplify it. It's that mess right there became secant. All right, I will do one more for you before we start our next lesson. So I can do 1, 2, or 4. Which one do you want me to do?
Somehow it's gonna be like tan, because you don't even see tan on the questions.
So am I doing 1, 2, or 4?
3.
1, 3, or 4?
3.
3? Alright, here I am again, walking down the sidewalk, and I come upon this problem. I don't know anything about anything, but I know exactly how I'm going to start this problem, because it is a fraction minus a fraction. And what do? Common denominator. So I'm going to do a common denominator. And the common denominator is going to be 1 minus sine times cosine. That's my common denominator. So this guy needs a cosine. Would you agree with that? Match. This one needs a 1 minus sine. There is nothing beyond you doing that. You can do that. You don't have to know anything about trigonometry to get a common denominator. Now, what's the top? What have I got up there? This is my denominator. So here I've got cosine squared. Please remember, you must have an x or a theta or something to your cosines and sines. You can't just write tan. It has to be tan x. Okay? All right, minus 1. Here I go. This is a distributive. So I'm taking minus sine times 1. Minus sine times minus sine. Positive sine squared. So I just distribute it. Negative sine. Take tattoo. What do you have in the top? You got a sine squared plus a cosine squared.
1.
So these guys right here add together and make 1. So now you've got 1 minus sine on the top. And on the bottom, you have 1 minus sine times cosine. Won't that 1 minus sine cancel with that 1 minus sine? And leave you with 1 over cosine, which is if you don't remember that 1 over cosine is secant, you can add that to your sheet. 1 over sine is cosecant. Okay? Alright, so I just did 50% of your homework. It's due on Thursday. I think you can manage to next. I just become. Okay. Alright, get your notes out now, and we're gonna forge ahead into 5-2, which is very similar to 5-1. I actually like these problems better because, like the one we just did, we just kept going. We weren't really sure when we were supposed to stop. These problems, you know exactly what you are to stop. Here's what I need. Sine squared plus cosine squared over cosecant is supposed to equal sine. So this is not an equation that you are solving. This is, you're proving that this will simplify into that. So it's like saying simplify this, but you know that is the answer you're supposed to end up with. Okay? So, we're not gonna mess over there, we're gonna mess over here. Do you notice anything at all about that?
What, you got one top?
One on the top. Now, wait a minute, guys, wait a minute. 1 over always means reciprocal. Think about it. What's the reciprocal of 3? 1 over 3? What's the reciprocal of 8? 1 over 8? So what I have here is a reciprocal of cosecant. What is the reciprocal function for cosecant? I just told you right on the paper. 1 over sine is cosecant. So 1 over cosecant is sine. 1 over cosecant is sine. So sine, this is sine x. This is, you don't need to write this down, but this is why it's like, this is 1 over sine. So you have 1 divided by 1 over sine. Isn't that 1 times sine over 1? The reciprocals are reciprocals. So, if you don't already have that memorized, you can add it to your sheet. 1 over sine is cosecant. 1 over cosecant is sine. 1 over tangent is cotangent. 1 over cotangent is tangent. 1 over cosine is secant. 1 over secant is cosine. Right? Write it down. If you don't know, put them on your sheet. But those are reciprocals. So that problem is done. You did exactly what you were supposed to do. You simplified this and ended up with that. All right, let's look at number 2. Can we do the same thing with number 2? Okay, so let's start. We got tan x over secant x. Okay. So I just heard Eli say tangent is sine over cosine. Along the same lines, what is secant? 1 over cosine. So isn't this sine over cosine divided by 1 over cosine, which means keep change flip? So sine over cosine times cosine over 1, and that ends ends up just being sine. Next time you see this, feel free, if you have a fraction over a fraction, and you have the same thing in the denominators, they will always cancel, because you're gonna flip that second one. So you don't have to write this out, you can just cancel right here. They have to be the same, and they have to be in the denominator. All right, one more. That's good. Let's try one more and see what we can do. All right, so I want you to look at it. And somehow we gotta end up with this. Okay? So I want you to look at it and think of something to do. Hey, think of something to do. Anybody see anything at all we can do to get started?
See what a zero means?
No, remember, we're not solving.
Oh, yeah, we're
We are trying to boil this down so it ends up right there. So we're not doing anything with that over there.
We can do
We're trying to match
sine
that.
distribute.
Sine.
Was that replace or
Tan X or Sin X or
Alden wants to distribute.
Okay. I think Alden has a great idea. When you
Job,
see a parentheses with something out in
Harper's
front of
original
it,
idea.
don't you think about distributing?
What?
So cosine tangent plus sine cotangent cosine. All right, so I am following Alden's lead. Now, I want you to look right here. Cosine is cosine. But tangent is what? What is tangent? Sine over cosine. So what happens, boys and girls, this is like cosine over 1. What happens when you multiply these two together? Don't those cancel? And so this just ends up equaling sine.
Halfway there.
Now, I'm hoping like heck that this ends up being cosine squared. Let's see. Sine is sine. What's cotangent?
Sine.
Cotangent. Cosine over sine. And that's just cosine. No cosines cancel, but the sines do. The cosines do not cancel because they're both in the numerator. But cosine and cosine is cosine squared. You good with that? All right. I'm gonna stop there. That's a lot.
Sphincter.
You got homework due for Thursday? No.